Alright, in problem number 4 we have a particle moving along the x-axis with an acceleration given by a of t is equal to cosine of t for t greater than or equal to 0. At t equals 0, velocity is 2 and the position is 5. The first thing we want to do is to write an expression for velocity. We know that velocity is the integral of acceleration, which in this case is the integral of cosine of t dt. The antiderivative of cosine is sine plus c. Now we're given that v of 0 is equal to 2. So v of 0 means we plug in 0 for t, and so we get sine of 0, which is 0 plus c is equal to 2, and therefore c is equal to 2. And putting it all together, then we get that v of t is equal to sine of t plus 2. And that's the answer to part A. For part B, we want to write the expression for the position, and position is just the integral of velocity. So we have the integral of sine t plus 2 dt. The antiderivative of sine is negative cosine t. The antiderivative of 2 is 2t, then plus c. Again, we're given that the initial position at t equals 0 is 5. So we have x of 0 is equal to negative cosine of 0 plus 2t, or 2 times 0, plus c is equal to 5. The cosine of 0 is 1, so we get negative 1 plus c is equal to 5, or c is equal to 6. And so we get that x of t is equal to negative cosine of t plus 2t plus 6, and that's the answer for part B. For part C, we want to find out for what values of t is the particle moving to the right, and justify the answer. And so we say the particle moves right when v of t is greater than 0. Since v of t, which is sine of t plus 2, is always going to be positive, the lowest that sine can be is negative 1, so it'll always be positive. So it's greater than 0 for all t, so the particle is always moving to the right. And that's our answer to part C. Finally, we want to find the total distance traveled from t equals 0 to t equals pi over 2. And the total distance traveled, only because we know the particle is always moving right, the total distance traveled in this case will be equal to the displacement. And the displacement is just the integral from 0 to pi over 2 of v of t dt, which is the integral from 0 to pi over 2 of sine of t plus 2 dt. And actually we know what that antiderivative is. We did it for x of t above, so all we really have to do is evaluate x of pi over 2 minus x of 0, which is by definition what the fundamental theorem says. The integral from 0 to pi over 2 of v of t dt is just x of pi over 2 minus x of 0. Now x of pi over 2, and you're going to see that the c doesn't really matter, which was 6 in this case, doesn't really matter, but we'll still work with it here. So we have negative cosine of pi over 2 plus 2 times pi over 2 plus 6 minus the quantity negative cosine of 0 plus 2 times 0 plus 6, and again you'll see that the 6's will just disappear, or 0 out. Now cosine of pi over 2 is 0, so that part goes away. And 2 times pi over 2 is just pi. Then in the second expression, cosine of 0 is 1, negative 1, so we're going to get minus negative 1, or plus 1, and so the total distance traveled from 0 to pi over 2 is just pi plus 1. And that's our answer for part D.